In this tutorial series, I will teach you how to create savable objects for your Unity games. The series will teach you how to do this both for 2D and 3D games, so don't worry if you are working on a 3D game and you see me using 2D sprites here, because everything is going to work the exact same way for a 3D game. I'm going to show you how to save the position, the rotation, and the scale of an object, and I'm also going to show you how to save some stats like speed and strength here. So if you have some extra things you would like to add, you should be able to do that by yourself when you are done with this series, because I'll show you how to set everything up. But let's have a look at it. If we play this game, we have three objects. We have a mushroom, a stone, and a crate. If I click on the crate, you'll notice that we have the speed and strength here, and I would like to increase the speed of this crate to 5 and the strength to 20. So he just leveled up this crate basically. The stones also gained a level, so they got 50 speed and 2 strength. And the mushroom, he also leveled up, but he only got 1 speed and 1 strength. So now we have changed something about our objects, but let's change some more things around. We can also take the crate and scale him up, like this. We can take the stone and rotate it and maybe also scale it up a little. And then we take the mushroom and scale it up, and we move it down here and rotate it a little maybe. You can also move the stone. And then we are going to save this by clicking the save button. We're going to stop playing the game. And when we play it again and we load the game, we should see all these objects in the position they had when we saved them. And as you can see here, the mushroom is down here rotated, the stone is here rotated, and the crate is scaled up here. And this functionality is of course also going to work throughout different levels. We will make sure to set it up so that it works on each level. So let's get started. So before we start programming the actual game, I would like to explain the structure to you. And what you see here in front of you is something called a UML Class Diagram. And this might look a little confusing, and maybe it's the first time you see one of these diagrams. So I'm going to make a very short explanation about UML Class Diagrams and about this structure. But of course there's way more to these diagrams than you actually see right here. These diagrams are actually used to design the program before you start the actual coding. And by designing it before you start coding, you'll actually be able to create a better structure for yourself, and you might be able to see which problems will appear when you start creating the different classes and prevent them by creating a good design. So usually when you just start coding, you might create some extra classes suddenly and you have to restructure some of the old code. But by doing this, there's a less chance of having to restructure your things. But of course, it's impossible to design a program 100% before you actually start. Before you actually start the programming. And of course, this class diagram, or not in this case, but usually when you make a big game, the class diagram is going to look different than the final finished polished product, of course, but it's a pointer in the right direction. If we look here, we have 4 different boxes, and each of these boxes down here in the bottom represents something called a class or a script. So by looking at this, we already know that we need a savable object script, a SafeGameManager, and a specific object script. Up here in the top, we have something called an enumeration, which is also something we're going to create, and it's basically your own little custom data type. And we can see this object type here can be a crate, mushroom, or a stone. So right here, I have the different classes. So we have a savable object, which is using the SafeGameManager, which is a singleton. And we can see that by the instance here. And we have a sprite object down here, which inherits from savable object, a specific object, that inherits from savable object, as we can see here, because there's this arrow here. And this arrow represents inheritance, or inheritance between 2 classes. This arrow here is a directed association, which means that savable object is using SafeGameManager without using a object instance of SafeGameManager because it has a singleton. It's a singleton structure. These boxes are divided into two areas. We have the top here, which is our fields, all our variables goes up here, and in the bottom we have all our functions. So I'm not going to explain everything inside these right now because I'm going to do it as I program the game so that you'll get a better understanding. But this is the base of the structure here. So now that we have an idea about the base of the structure, we can start adding these classes. So if you open up a new Unity project, the project I have made is a 2D project, but you can do whatever you want. You can make a 3D project if that's what you want, because this functionality is also going to work with 3D, of course. First of all, I will need to add some sprites to my game so that I have some objects to save. And this is the part where you will have to add your 3D models if you're using 3D, or you'll just have to go to create and you can use like 3D objects here to add and add them. But I'm going to use free sprites, so I'm going to take a crate, I'm going to take a mushroom, and I'm going to take some stones here. And I'm just going to have some order, so I'm just going to make a sprite folder and add all of these sprites to this folder here. Okay, so now I have the sprite folder. What I want to do is to add a folder for all my scripts because I would like some better order. So I right click on the asset folder, click create, click on folder and write scripts. Now I have a script folder. If we look here, we'll see that we need to create a what's called a class or a script called savable object. So we go back here, go to scripts, right click, create script, and we write savable object. Besides the savable object, we will also need to create a specific object. So specific object is just a name I'm creating here, but in your game you can of course call the specific object player, power up, tree, or whatever it is going to be in your game. A specific object is just a general name for what it would be. So I'm just going to create, and I'm going to make a C# script and call it specific object. The last class we'll need is a SafeGameManager, and the SafeGameManager is going to handle all the saving. So when you click a save button in your game, it's going to call the SafeGameManager and save everything in the game. And we also need to make the SafeGameManager into a singleton, but we'll get to that. So let's try to right click, create C# script, SafeGameManager. So now we have created all our scripts here. So let's start creating one of the scripts. If we look here, we can actually start with the savable object here. And let's try to open up the script and make it match this, this class we see here in the UML diagram. So let's go back to Unity and click on the savable object here. And I'm just going to move Visual Studio in here so we can see what we're doing. And if you look at the diagram here, if I can grab my edges of this here. So if we look at the diagram, the first thing that comes to notice is this SafeString. So when we save something in our game, we will actually add it as a string, and we will save it with something called PlayerPrefs. But I'll explain that when we get to it. But first of all, the savable object needs a string, so it needs to translate its position, its rotation, and all these things into this string before we save it. So if we look at the diagram as well, you'll see that there's this little pound sign or hashtag or whatever it's called in front of it, and it means that it is protected. So these different signs in front of the variable and the classes or the functions describes the accessor level or the access modifier on each object or each variable. I'm not good at talking right now apparently. So this save function or this save variable needs to be protected, and it needs to be of type string. So you might be wondering, why isn't this written like it is in C#? Well, UML was not made for C# and C# is made after. So UML is a language or a diagram type that actually uses terms from general programming, so that we can't translate everything directly to C# because it's made for other programming languages as well. If we would make this in C# style here, well, then other programming languages wouldn't be able to take this and use these diagrams. So this is a protected string called save. So let's jump back in here and make protected string save. Underneath we have an object type, and if we look up here in the top, we have the object type as an enumeration. So we will have to create this enumeration before we can actually create the object type here. So if we jump back here and go up in the top here and write enum object type. So an enum is basically your own data type, so we're creating our own data type for this. You could argue we can use the names of the objects to save the type, or we can use the sprite it has or something. But right now I'm just going to use the object type. You can also use the name of the object if that's what you want. So object type. And then we have to define the different object types that our game can have. And in the diagram we defined that we need to make a crate, a mushroom, and a stone. So jump back here and write crate, mushroom, stone. So these are our three object type. And in here we have a minus in front of the object type, which means that the object type is actually a private variable. So we have a private variable of the type object type, and it's called object type with non-capital O. So we have to write private object type here, object type. And the reason that I'm not using capital O here is because that our needs to be private. Is because that our object type class, or not class, the enumeration is called with a capital O, so we can't call this one object type. It will give some confusion later when we need to call it down here, which is this one or the object type. So just to make sure that we don't confuse them, write object type with non-capital O. Okay. What's next here? Let's have a look again at the diagram. So we need to have a private start function, and usually in Unity we have the start function already, and when there's written nothing in front of it, it's always private. But it's a good manner, or like good code convention, just to write private anyway, like this. But it doesn't change anything from the function. It's just easier to read and understand for other people when they read through it, to see what's private and what's not private. What else? We have a save, load, and a destroy savable object function. Okay, so right now we don't have an update function in here in this diagram, which basically means that we can go in here and delete the object function, update function. So let's create the save function, and it takes a parameter, as we can see, and it returns a void. So it takes a parameter which is an integer called ID. So when we save each object, we give them an ID and save them in the game, so we know which object to load when we load, so we can look at the ID. So let's take a was it public? Let's see. Yeah, it's public because there's a little plus in front of it, which makes it public. So public save, and we call this int ID. And as you can see here, we're missing something, because you can see it has a void return type, so it doesn't return anything. So we have to go in here and write public void. So that's the function. Let's see the next one, load, and it takes a string. This should be written string here. It takes a string array called values, and it returns nothing. So let's try to do that. Public void load. It it's a string array called values, and it returns nothing. That's why it's void. And the last function is called destroy savable, and it returns nothing. And it's also public. So public destroy void destroy savable. So now we have actually already made the structure here. And of course the UML diagram doesn't say anything about what goes in the class and so on. But that's up to you to put stuff in there, and we know what's going to go there. We can't put the code inside the diagram, of course. Underneath here, we have a specific object. And the specific object has two variables, and this is just for testing or for showing that you can save the variables in the object. So normally a crate, a stone, or a mushroom wouldn't have speed or strength, but I'm just showing that you can save the fields. Let's say that you have a player or an enemy, for example, and you would like to save the enemy with some different stats and stuff. So I just added them here to the specific object. So this specific object could also be an enemy, of course. So that's why it has speed and strength. So let's go to the specific object. And inside the specific object, we will have to look at the UML diagram. We have a private float called speed and a private float called strength. So let's make them. Private float speed, private float strength. If I spell, there we go. Okay, so here comes another part. As you can see here, we have a save and a load function in our specific object. But our specific object inherits from our savable object, which means that it needs to override the save and the load function, because these functions down here are identical to the functions that you are inheriting from the savable object. So this tells us a little about the structure here. So we need to override up here, and we need to make these up via virtual. But let's look at it. If we open up the game, the script, we'll need to make sure that specific object inherits from savable object, because all the general functionality is up here in the savable object, and all the specific functionality is down here in specific object. And the reason we make this inheritance is so that we don't have to make a crate and a mushroom and an enemy and a tree, for example, with the savable string and object type and start and the destroyable function and so on. And the reason we do that is because then we will put all the specific stuff up here, all the general stuff up here and the specific down here, so that we save the code so we don't have to make it over and over again. So this saves us from creating the same functions multiple times and the same variables multiple times. We needed to override the save and the load function, and we need to inherit. So if we go to this specific object here, we'll need to inherit from savable object, and we do that by writing savable object here after the colon. So this indicates that our specific object inherits from savable object. And as you can see up here, just to show you, we have this protected string called save. Because specific object inherits from savable object, you can actually access save down here, and you can access all the functions that are public. So you can see we can access destroy savable object and the save function, and we can access the save variable. So this means that specific object is of type savable object now, so they can be considered a savable object. So the next part is that we need to override our save and load function. And let's just try to write it, then you'll see something. So we say, if I write public override, then you can see I don't get any options to override save and load. And the reason I don't get these options is because to override something in C#, you'll need to state that you should be able to override the specific function. And you do that by the virtual keyword. So if we jump back here, we need to make public virtual void save and public virtual void destroyable, not destroyable, sorry, this is load, I need to do it too, public virtual void load. So the reason that we are overriding these is because the save function in the savable object is going to take care of all the general saving. So everything that needs to be saved, like rotation, position, and so on, needs to be saved in the savable object, and all the specific stuff like speed and strength and so on needs to be saved down here in the specific object. So now these two are virtual, so we go down here and say public override virtual, not virtual, sorry, we can just write, and then we want to override load and public override void save. Now you can see we can override them. What this does is that it calls the base save function and the base load function, which is the specific object's save and load function here. So if we have some functionality here for saving the position, for example, well, then it's also going to be called when we try to save the specific object. If we remove the base here, well, then it's never going to call the savable stuff up here. Yes, so that was those two functions. Now we have structured the specific object. And we haven't, of course, put anything in them, but I'll wait with that for the next video. So the next thing we'll need to do is to create our SafeGameManager. So let's do this, and then I'll end this video and move on to the next one. So let's jump into our SafeGameManager. And if we compare, we have an instance called SafeGameManager, and it's private. So you'll notice there's an underline here, and when something is underlined, it means that it's something called static. And static can be accessed on the class level. So let's just try to make it non-static first and then convert it into a static afterwards, so you can see the point. And what else? Let's see, did we have a start? We have an awake, but we don't have a start and an update. So we can delete update, and we can rename this to awake. So we need to create a private, if I could, private SafeGameManager called instance. And this is the structure of the singleton. And the singleton is a design pattern that is used to access one object, access a specific object. And when it's a singleton, there should only be one instance of that object. And that makes it easier to access it than just having a reference to a specific object. That's a very short explanation, maybe not a very good one. But basically you just need to think this structure we are creating here makes it easier for us to access the SafeGameManager anywhere in our game and save everything. So maybe you would like to be able to save during a menu or something. Then the menu can take this SafeGameManager and call the save function and save everything. Yeah. So let's see. We need to create a structure here. So this SafeGameManager, this function here, structure here is going to be the singleton structure. And we can see we have this something called getInstance right here. And because we're using C#, we can actually use something called a property instead of making a function called getInstance. And this is actually a function, property. So instead of having a function called getInstance, we just make this property here. And in here we'll have to say if instance is null. Well, then we're going to say instance equals GameObject.find object of type GameManager. There we go. So this is going to call this find object of type when we call the GameManager first time. So if it doesn't exist, it's going to set the instance, and then it's going to return the instance so that we can actually access it from outside this game object here. So this one is public, and this one private, and this one is public. So we need to use the instance with a capital I to access this whole class here. And again, yeah, the singleton instance is an easy way to access the SafeGameManager at all times, and it's a Good thing to do when you need to have a game object, for example, instead of having a static class. But we're just going to use the Singleton instance. So right now, if I went to the specific object and I would write SafeGameManager dot instance, I'm not able to access the instance right now. And this means that I would need to find a specific object. I would say game object, game manager, and I would say game manager.get component, save game manager, and I would have to say, and here I can access the functions on the game manager. Let's say that the game manager had the save function, public void save, and in my specific object I would have to say that save here. So now I access the save game manager just because it's like not assigned here. So now I can access the save game manager save function. But if I would change this into a static, so I say private static, public static, you should do this, make it static, then I'm able to access all this on the class level. So I can go back here and I can say save game manager.instance.save. There we go. So now we just saved everything just by doing this. We don't need to find an object, we don't need to access the script, we don't need to call the function on that script we just accessed, and so on. So this is why a singleton is so handy for us. Yes. Okay, we need a list of savable objects. So we need to write, what was it? It was private. And then down here we have something called get savable objects. And because we're using C#, we can make a property for it. So let's just make a property. And it's going to be a list. And as you can see here, the list is not on here. And that's because we need to include the correct namespace up here. So we need to write using system.collections.generic. So now if we write list, you will see that the list comes up, and we need to define what the list contains. It needs to contain savable objects, and we just call it savable objects with an S. As you can see here, the set is private and the get is public. So we need to say private set here. And this just means that we can't set the objects from outside. We can't change the list, reinstantiate the list from outside. Yes. In the awake function, let's just wait with putting stuff in them. We have a save and a load function. Public void save. We have load. We already have save, so we make load. And then we have a string to vector function and a string to quaternion function. Point is that string to vector should translate a position or a direction to a string so that we can save it. And string to quaternion should save take a rotation and transfer it into a string. Other way around. Should take a string and transfer it into a rotation so that we can load it. So I think I said save before, but these two functions are for taking whatever we saved and transfer it into an actual object value. So we take we load a string with a position and we change it into an actual vector so that we can load it in the game. Yes. So string to vector. Oops, like this. Public void string to vector, and it took in a string called vector, I think so, let's see, called value. And as you can see here, here's a mistake, because it says that it returns a vector free. It's not a void function like the others here, so we have to change the void to vector free. So we need to return the vector it translate. Just return null for now. Okay, let's just return vector 3.0 then. And then public quaternion string 2 quaternion, and it takes in a string called value, and return quaternion dot, can we return anything? Identity. Okay, so we need to change these 2 lines, but this is just for now so we don't have any errors. Okay, and there you have it. Now we just created the whole structure here without anything inside them, but we created the structure. And in the next video we are going to have a look at the actual code inside these different functions. So thanks for watching, and by the way, if you haven't done it, then follow me on Twitter, like my Facebook page, and don't forget to subscribe to this channel to get the updates for next video. Remember that InScope Studios is a community-based site and community-funded site, and so that means that every support from you is very, very important to me. You can support me in different ways. You can go to the Patreon page and support me there for a fixed amount a month, and if you do that, you will be able to get some different perks like programming training, tutoring just from me. You will get all my projects that I make, and they will be downloadable to you. And if you are not interested in supporting me like that, it will also help me out a lot if you simply just acquire one of my projects from the link in the description or the link on the screen right now. You can either get this project or any of my other projects to support me. So thank you very much for watching.